For weeks now, one question has continued to surface whenever people discuss the disappearance of Nancy Guthrie. If investigators knew where to look in the Arizona desert, would there still be evidence waiting for them, even after all this time? It is an uncomfortable question, but it is also one that forensic scientists have spent years trying to answer. According to researchers who study decomposition in desert environments, the landscape can preserve clues in ways that many people would never expect. Tonight, we're taking a closer look at what science says investigators may be up against, and why the desert itself can become an important witness long after someone has disappeared. Before we begin, welcome back, and thank you for spending part of your day with me. If you enjoy thoughtful, evidence-based discussions about ongoing investigations like this one, I'd love to have you join our community by subscribing. We have many new viewers each week, and your support allows us to continue taking these deeper looks into stories that deserve careful attention. The latest conversations surrounding the Nancy Guthrie investigation have once again focused attention on the desert. According to reports, one of the ransom notes claimed that Nancy had been buried with nature. Those words immediately sparked questions among investigators, journalists, and viewers alike. Were they meant to be taken literally? Were they simply intended to mislead? Or was there some truth hidden behind the statement? At first, that seems straightforward. Most people picture a grave whenever they hear the word buried. They imagine a hole dug deep into the ground and carefully covered over. But Arizona's desert is very different from what many of us imagine. Beneath a relatively thin layer of loose soil lies something called caliche, an extremely hard layer of earth that scientists often compare to concrete. Digging through it isn't like digging through the soft ground found in many other parts of the country. According to researchers familiar with the region, it can require heavy equipment rather than an ordinary shovel. Welcome back, everyone, and thank you for being here. If you enjoy thoughtful, evidence-based investigations like this one, please take a moment to subscribe to the channel. Your support helps us continue bringing you well-researched stories and updates as new information comes to light. That small detail changes the conversation. If someone wanted to conceal evidence in an untouched area of the desert, creating a traditional grave might be much more difficult than television dramas often suggest. Investigators who have worked in Arizona have pointed out over the years that the terrain itself presents enormous challenges, both for anyone attempting to hide evidence and for those trying to recover it. That brings us to a fascinating scientific study that has attracted attention well beyond academic circles. At Arizona State University, researchers began asking a simple but important question. If a body is left on desert soil and later moved somewhere else, does the original location continue to tell a story? To explore that question, researchers used pig models dressed in human clothing, a common practice in forensic research because pigs share many biological similarities with humans during decomposition. The animals were placed in separate locations in the Arizona desert for several weeks before being moved. One was positioned beneath a mesquite tree, another remained fully exposed under the desert sun. The goal wasn't to recreate a crime scene. Instead, the researchers wanted to understand how the surrounding environment changed after decomposition began. When the bodies were removed, the desert appeared almost unchanged. Wind had swept across the ground. Temperatures had risen and fallen through the changing seasons. Rainfall remained scarce. Looking at the locations with the naked eye, someone might reasonably conclude that nothing unusual had ever happened there. But appearances can be deceiving. More than a year later, scientists returned to collect soil samples from the exact places where the pigs had originally rested. Their expectation was fairly modest. Given the harsh desert conditions, they believed nature may have erased nearly every trace. Instead, the laboratory results surprised even the researchers themselves. According to the study, the soil still carried distinct microbial signatures that differed from nearby, untouched ground. Certain bacteria associated with decomposition remained present, even though the bodies themselves had long since been moved. Chemical changes within the soil also remained detectable. In other words, the desert had remembered. That's an extraordinary finding because it suggests that physical evidence isn't limited to bones, clothing, or personal belongings. Sometimes, the ground itself becomes part of the investigation. Of course, it's important to understand what these findings do and do not mean. The research does not suggest investigators can simply walk into any desert location and instantly identify where a person may have been. The process requires careful sampling, laboratory testing, and often a reasonable idea of where to begin looking in the first place. Without that starting point, the Arizona desert still covers thousands of square miles, making searches incredibly difficult. Even so, the study offers an encouraging reminder that nature doesn't always erase evidence as quickly as many people assume. Another detail makes the research especially interesting. The scientists didn't simply study decomposition. They also examined whether clothing could leave behind its own chemical traces. Synthetic fabrics, as they slowly break down, may introduce elements into the surrounding soil. That means investigators could potentially learn not only that a body had once been present, but also gather clues connected to what that individual was wearing. These are highly specialized forensic techniques, and according to researchers, they require knowing what evidence to test for, rather than relying on a single machine to reveal every answer automatically. Real forensic science is rarely as simple as it's portrayed on television. It involves patient laboratory work, careful comparisons, and repeated testing before conclusions are drawn. Meanwhile, investigators in missing person cases continue to face another reality unique to the Arizona landscape. The desert is constantly changing. Wind shifts loose sand. Seasonal weather alters the terrain. Wildlife moves through remote areas. Every passing month creates additional challenges for search teams attempting to recover evidence. Yet despite those obstacles, science continues to improve. Each new study gives investigators another tool that may someday help answer difficult questions in cases that have remained unsolved for years. And when those scientific findings are viewed alongside the claims made in the Nancy Guthrie ransom notes, another important question begins to emerge. If the desert can preserve microscopic evidence for much longer than expected, could investigators someday recover information from places that previously appeared to hold nothing at all? That possibility brings us to another remarkable part of this research, because scientists didn't stop after the first year. They went back again, and what they discovered after even more time had passed raised another set of intriguing questions. When the researchers returned to those same test sites again, they weren't expecting the desert to hold on to its secrets indefinitely. More than 2 years had passed since the original experiment began. Arizona had gone through another scorching summer, another dry season, and countless days of blazing sunlight. If nature was ever going to erase the evidence, this seemed like enough time for that to happen. Then something unexpected happened. The results from the two locations weren't identical. The site beneath the mesquite tree had gradually begun returning to what scientists called its control condition. In simple terms, the bacteria in that soil started to resemble the surrounding desert again. The unique microbial signature left behind during decomposition had largely faded. The second location told a different story. The pig that had been left fully exposed beneath the open desert sky produced soil that remained noticeably different from the surrounding ground, even after more than 2 years. According to the researchers, statistical analysis still showed measurable differences between that soil and nearby untouched areas. That finding immediately raised another question. Why would the exposed location preserve evidence longer than the shaded one? At first glance, many people might assume direct sunlight would destroy biological evidence more quickly. The Arizona desert is known for temperatures that regularly climb above 100 degrees during the summer. Common sense might suggest that heat would simply bake everything away. But according to the researchers, the explanation may actually have had more to do with the tree than with the sun. A mesquite tree creates its own small ecosystem. Throughout the year, it sheds leaves, attracts insects, supports different microorganisms, and provides shade for wildlife. All of those natural processes continually disturb the soil beneath it. Over time, that activity appears to blend the decomposition signature back into the surrounding environment. The open desert, by contrast, remains far less active. Without the constant biological changes taking place beneath a tree, traces in the soil may persist longer than expected. That may sound like a small scientific detail, but it highlights something investigators often emphasize. Every scene is different. A body left beside a wash, beneath a tree, near a rocky hillside, or out on open desert ground may leave behind very different forms of evidence. Investigators cannot assume one location behaves exactly like another. That would have been the end of it, except another part of the research opened an entirely new avenue of forensic investigation. The researchers also examined the clothing placed on the pig models. In many criminal investigations, clothing receives immediate attention because it can contain fibers, DNA, fingerprints, or trace materials. But scientists wanted to know whether the clothing itself could alter the surrounding soil. According to the research, certain synthetic fabrics slowly release chemical compounds as they deteriorate. Those compounds can become part of the soil's chemical profile. Imagine a jacket made from synthetic fibers lying in one location for weeks. As heat, moisture, and decomposition take their course, tiny amounts of material may seep into the ground. Long after the clothing has been removed, sensitive laboratory testing could potentially identify unusual chemical patterns. Again, this isn't something investigators simply discover by glancing at the ground. The process requires careful laboratory analysis and knowing exactly what compounds to search for. As one researcher explained, forensic science doesn't work like television crime dramas, where a machine instantly reveals every answer. Scientists usually begin with a specific question and test for specific substances, rather than searching blindly for anything unusual. That distinction is important. Television often gives the impression that forensic laboratories solve mysteries in a matter of minutes. Real investigations are much slower. Samples are collected carefully, preserved, documented, compared with controls, and reviewed repeatedly before investigators place confidence in the results. For families waiting for answers, that process can feel painfully slow. The Nancy Guthrie investigation has reminded many people just how difficult missing person cases become once time begins to pass. Every season changes the landscape. Wind reshapes sandy areas. Heavy monsoon rains can wash away surface evidence. Animals move through remote regions. Vegetation grows and dies back. The clock is never on investigators' side. Even so, forensic science continues moving forward. Another aspect of this research focused on one question investigators often face after receiving anonymous tips. Suppose someone claims a body was once left in a particular location but later removed. Years ago, investigators might have had little reason to examine that ground if no obvious evidence remained. Today, microbial and chemical analysis may offer another opportunity to determine whether decomposition once occurred there. That doesn't mean every anonymous tip becomes credible. Far from it. Law enforcement still has to evaluate whether information is reliable before committing valuable resources. False leads consume time, money, and manpower, and they can divert attention away from more promising evidence. That's one reason investigators remain cautious whenever new claims emerge in high-profile cases. According to public reporting, the Nancy Guthrie investigation has generated numerous theories over the years. Some have come from anonymous sources. Others have spread widely across social media before being verified. Investigators have consistently urged the public to distinguish between speculation and confirmed evidence. That careful approach is especially important when discussing the ransom notes. The wording in those notes has fueled countless debates. Were the statements intended to provide clues? Were they designed to mislead investigators? Or were they simply written to create fear and confusion? The exact answers remain unclear, but science gives investigators something more reliable than interpretation. It gives them measurable evidence. If a location can be identified through witness statements, digital records, surveillance footage, or other investigative work, forensic specialists now have increasingly sophisticated methods to examine what may have happened there, even long after visible signs have disappeared. There is another challenge unique to Arizona that often receives less attention. Thousands of square miles of desert stretch across the state, much of it isolated and difficult to reach. Search teams often work in intense heat, navigating rough terrain where every mile requires significant effort. Helicopters, drones, trained dogs, volunteers, and experienced investigators all play important roles. Yet even with modern technology, locating a single specific area can be extraordinarily difficult. And that brings us to perhaps the biggest question raised by this scientific research. If the desert can preserve microscopic evidence for years, how should investigators decide where to begin looking in the first place? Because finding the right location may ultimately matter just as much as understanding the science itself. If there's one lesson investigators have learned from decades of missing person cases in the American Southwest, it's that the desert rarely offers easy answers. From the outside, it can look empty. Endless stretches of sand, rocky hillsides, dry washes, and scattered mesquite trees all begin to look the same after a while. But to trained investigators, every section of that landscape tells its own story. The challenge is learning how to read it. That's why forensic researchers continue refining techniques that may help law enforcement identify places where a body may once have been, even if that body is no longer there. According to the Arizona State University researchers, their work is still ongoing. The original study served as what scientists often call a proof of concept. In other words, it demonstrated that decomposition can leave measurable microbial and chemical changes in desert soil. The next step is repeating those experiments under different conditions to see whether the findings remain consistent. Science depends on repetition. One successful experiment is encouraging, but researchers want to know whether the same patterns appear again and again before drawing broader conclusions. That careful approach mirrors the way criminal investigations are conducted. Investigators rarely rely on a single piece of evidence. Instead, they build a case by comparing independent findings. A witness statement may be compared with phone records. Surveillance footage may be compared with vehicle movements. DNA evidence may be compared with laboratory testing. Each new piece either strengthens the overall picture or raises additional questions. The same principle applies to forensic science in the desert. A microbial signature alone doesn't solve a missing person case. Neither does a chemical change in the soil. But if those findings line up with witness testimony, search records, digital evidence, or information from an ongoing investigation, they become one more piece of a much larger puzzle. That brings us back to the Nancy Guthrie investigation. Since Nancy disappeared, countless theories have circulated online. Some suggest she may have been taken across state lines. Others speculate about remote desert locations or burial sites. There have been discussions surrounding ransom notes, anonymous messages, and reported sightings. Some claims have generated widespread attention before later being questioned, while others have quietly faded away. Throughout all of that, investigators have remained focused on something much simpler: Evidence, not assumptions, not internet speculation. Evidence that can be documented, tested, and verified. That's an important distinction because high-profile cases often attract information from every direction. Some tips prove valuable, many do not. Investigators must separate genuine leads from rumors, and that process can take months or even years. The scientific research we've discussed today doesn't answer where Nancy Guthrie is. It doesn't confirm that any statement contained in the ransom notes was true, and it certainly doesn't identify a specific location investigators should search. What it does show is something both hopeful and sobering. Hopeful because nature doesn't necessarily erase every clue. Sobering because those clues still have to be found. Imagine standing in the Arizona desert on a summer afternoon. The sun is high overhead. Heat shimmers above the ground. A warm breeze carries fine dust across the landscape. There are no footprints, no obvious signs of disturbance. Nothing immediately catches your attention. To most people, it would appear that nothing had ever happened there. Yet beneath the surface, microscopic organisms may tell a very different story. Bacteria, invisible to the human eye. Tiny chemical changes. Altered soil composition. None of it dramatic, none of it obvious. But together, those details can become valuable evidence when examined by trained forensic scientists. Another encouraging aspect of this research is that the technology needed to perform many of these analyses is becoming more widely available. Universities continue studying decomposition under different environmental conditions, while forensic laboratories improve their ability to analyze DNA, microbial communities, and chemical signatures. Each advancement adds another tool to the investigator's toolkit. Of course, no scientific method is perfect. Researchers themselves openly acknowledge the limitations of their work. Desert conditions vary from one location to another. Temperature, rainfall, wildlife, vegetation, and soil composition all influence decomposition. Human cases are also more complex than controlled research studies. That's why scientists are careful not to overstate their conclusions. Instead, they continue gathering data, repeating experiments, and refining their understanding of what the desert can reveal. There is also an important human side to this story. Behind every forensic study is the hope that one day it may help bring answers to families still searching for loved ones. Across Arizona, organizations continue working with families of missing persons, law enforcement agencies, forensic specialists, and volunteers who share a common goal: identifying the unknown and bringing people home whenever possible. For those families, every scientific breakthrough matters. It may not solve a case overnight, but it may help investigators ask better questions, search more effectively, or recognize evidence that might once have gone unnoticed. Those small advances add up over time. As for the Nancy Guthrie investigation, many questions remain unanswered. Were the statements contained in the ransom notes intended to reveal the truth, or were they written to mislead investigators? If evidence does exist somewhere in the Arizona desert, has it already been overlooked, or is it still waiting to be discovered? And if future forensic techniques continue improving, could evidence that seems impossible to detect today become visible tomorrow? At this point, the honest answer is that we simply don't know. But history has shown that cold cases sometimes move forward because of scientific advances that didn't exist when the investigation first began. Techniques improve, new evidence emerges, old evidence is examined with fresh eyes. Investigators revisit places once thought to hold no answers. Sometimes those efforts change everything. Other times, they simply eliminate another possibility. Either outcome helps move an investigation closer to the truth. As always, we'll continue following credible developments in the Nancy Guthrie investigation and separate verified information from speculation as new evidence becomes available. I'd also like to hear your thoughts. After hearing what forensic researchers have discovered about the desert's ability to preserve microscopic evidence, do you think these kinds of scientific techniques could eventually play a meaningful role in long-term missing person investigations? Let us know your perspective in the comments, and if you enjoy thoughtful, evidence-based discussions like this one, please consider subscribing so you won't miss future updates. Thank you so much for watching, and I'll see you again in the next investigation.